All right, 4, 5, and 6 have to do with angular and linear speed. For angular speed, it's how fast your wheel is spinning around. Linear speed, how far a distance does that cover? So it says a Ferris wheel at a carnival has a radius of 36 feet. Suppose it turns at a rate of 70 revolutions per hour. Do not round any intermediate computations. Round your answer to the nearest whole number. We want to find the angular speed in radians per hour. Well, we know the speed in revolutions per hour. So we want to convert our revolutions into radians. We know that 1 revolution is 2 pi radians. So we want to do our conversions. Since I want to cancel out the revolutions, I want 1 revolution on the bottom. That means the 2 pi radians would go up on the top. And then I got to grab my calculator. Again, for pi, I would use the pi button on the calculator so that you don't get any rounding issues. But basically there, we're just going to take 70 times 2 pi. So 70 times 2 pi gives me 439.8. We're rounding them off to the nearest whole number, so we're going to round that off to 440 radians per hour. The next part there, we want to find the linear speed. The linear speed is how much distance it would cover if it was rolling along the ground. And so for the linear speed, we're going to take the radius times the angular speed. Told us right up here that the radius of our carnival wheel is 36. So we're going to take the 36 times, and we don't want to use this rounded off number. So we want to go back to what we did for our calculation in order to get that number, 70 times 2 pi. That's going to give us our answer in radians per hour. We want it in per minute instead of per hour, so that since this is in per hour, we want to change, or we want to take that 1 hour is 60 minutes. And so I'm going to take 36 times 70 times 2 pi. I'm going to hit equals there, and then I'm going to divide it by 60. And I'm coming up with 263.89. So I'm going to round that off to 264. Since this was in feet already, we didn't have to change that. That's in feet. And now it's per minute, since we changed our hours to minute. So 264 feet per minute would be my answer. So we took our radius times our angular speed, and then we had to convert our units. Since this was in per hour, we needed to change it into minutes. So number 5 says, suppose that Uranus rotates on its axis once every 17.2 hours. The equator lies on a circle with a radius of 15,881 miles. Do not round any intermediate computations. Round your answer to the nearest whole number. So we've got 1 revolution in every 17.2 hours. We want to change it into radians per day. So if I first of all deal with my hours, we know that there are 24 hours in a day. So that will give me revolutions per day. We want to change our revolutions into radians, and so we know that 1 revolution is 2 pi radians. so that our revolutions cancel out, our hours cancel out, and we get radians per day for our units. So we end up taking 24 times 2 pi. I'm going to go ahead and hit equals for the top number, and then I'm going to divide it by the 17.2, which is on the bottom. And so I end up getting 8.76. I'm rounding to the nearest whole number, so I'm going to say 9 radians per day. So 9 radians per day. Then we want to find the linear speed. We know that the linear speed, we're going to take the radius. The radius is 15,881 miles times our angular speed. But again, we want to be careful that we don't use the rounded off. So I'm going to use the 24 times the 2 pi divided by the 17.2. And that's radians per day. We want miles per day, so we've got the right units. So I'm just going to go ahead and punch that in. So 15,881 times 24 times my 2 pi. I'm going to hit equals, and then I'm going to divide that by my 17.2. And I'm coming up with 139,232.46. So 139,232 miles per day would be my linear speed. So on number 6, it says that a cyclist is riding a bicycle whose wheels have a diameter of 30 inches. Suppose he is traveling at 22 miles per hour. We know that 1 mile is 5,280 feet. Do not round any intermediate computations and round your answer to the nearest whole number. We want to find the angular speed of the wheel in radians per minute. Got a little typo on there. So we know that we are going 22 miles in 1 hour. I want to go per minute. So 1 hour is 60 minutes. I also need this, whoops. So that I can change it into radians, but since my units up here is in inches, I have to change my miles into inches. So I am going to say that I have, let's see, 1 mile is 5,280 feet, but then I have to change my feet to inches. 1 foot is 12 inches. So I'm going to take 22 times 5,280 times 12. I'm going to go ahead and hit equals. I'm going to divide that by 60. So we have 23,232. This is in inches per minute. We know that the diameter of the wheel is 30 inches, so if I divide that by 2, the radius is 15 inches, so we would have 15 inches times that angular speed. So what we end up having to do to change it to radians per minute is that we end up having to divide by that diameter of 15. So I'm going to take my 23,232, I'm going to divide it by the 15-inch diameter, and I get 1,000 1,548.8, so I have to round that up to 1,549. Now it's in radians per minute. Now we want to change that into how many revolutions per minute. And so I'm just going to use this one since it wasn't rounded off too far. 23,232 divided by 15 is in radians per minute. I want to make it revolutions per minute, so I'm going to change radians. 2 pi radians is 1 revolution. So I'm going to use my conversion for radians, making sure the radians are on the bottom so they cancel out. So I'm going to take my 23,232. I have to divide that by, and since there's more than one thing on the bottom, I'm going to use parentheses. So parentheses, 15 times 2 pi, close my parenthesis, and I get 246.49. So rounding that off, 246, and that would be in revolutions per minute. And you do need to be careful here, since you've got more than one thing. You can either put parentheses around the bottom or do this divided by 15 and then divide that by 2 pi. That would also work. So it might take some practice trying to figure out how your calculator works, but I did the 23,232 divided by, and in parentheses, put my 15 times my 2 pi.